So now this is a getter and setter function. So if you ever want to get, like, if you want to get the address, you can use this. If you want to get index, you'll use this. If you want to set address, set index. So since these are private, we can't access them directly. So that's
Address
why
of
we have
what?
to
Dude, address of what?
address in the literature. Let's say in the
अच्छा
symbol
अच्छा वो
table.
100 110 वगैरह वाले एड्रेस
Uh,
सब्स्टिट्यूशंस वो
uh,
सब ना. ओके.
uh. Okay. Now the other function, sorry, the other class is this.
इंडेक्स वाला उसके लिए
Uh,
ना टेबल के अंदर उसका क्या इंडेक्स होगा?
oh, yeah, the index like 0, 1, 2, 3. Whoa. Who's this? Can you? Yeah. Okay. So now we have the inst table.
जस्ट अ सेक, वो जो तेरे इंडेक्सेस थे वो मतलब टेबल के इसके लिए था या मतलब जो निमोनिक्स में 0 1 वगैरह करता है उसके लिए था?
Uh, it's for the. It's like this 1, 2, 3, 4. It's just what you call.
अच्छा 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 वो
More like
लाइंस
a
के लिए ना
table.
बस.
Yeah,
Harshit, your
that's
naming
how.
conventions are very different from what is actually
This is not
given in
my
the.
code, no. This is not my code.
या अबे जो कोड सबके पास है वही वाला है ना, फिर कोई अपना खुद से थोड़ी ना करेगा.
Yeah. So now we make a new table, inst table.
ओके.
Hello.
या
Somebody left. Yeah. Someone's leaving and joining. Okay. So a hash map is basically a dictionary which maps strings to integers. Okay. So we need similar directives. We need registers. Is cc is the for checking larger, like for example, less than or equal to
कंडीशनल कोड्स ना.
greater than conditional codes. Yeah. DL is for the
डिक्लेरेटिव.
declarations. So we declare these, and then this is the constructor, and we just for every single command we just map it to some integer. Okay, so that's so like you'll have to remember it. You can put any order that you want, and you can uh,
No, it's
add
not
the
any
integer.
order. It's the same order which is given in the mnemonic table, the book. It's a specific order.
Yeah.
So it's
It's always a
codes and
specific order.
upwards.
Yeah.
For example, imperative statements they are from 0 to 10. So
हाँ
you have to
वो
put
उनके
it
ऑर्डर
वैसे ही
सेट है.
order में.
Okay.
So
कोई
it's just
बात नहीं,
not
एक्सटेंड
random
करते समय
integers.
बुक लेके बैठ जाएंगे उसमें क्या.
Yeah, that's okay. So now we have get type. So basically we enter a let's say we enter 4.
कैरेक्टर.
Okay. We enter some, no, not 4. We enter like
सपोज
Dereg,
ऐड
dereg,
ऐड नाम का ऐड कर दिया.
add.
let's say we enter start. Then it checks key. Okay, this key. It checks if AD contains this key, and it does.
Okay.
And contains key. Yeah, this time we have the code. Like for example, if we have 4, it checks if it contains these keys. If it contains the keys, then we get for example, we get. Let's say we have 4. It'll give us dereges output because
चलो ठीक है, की से वो ए रैक बी रैक वगैरह हो जाता है. अब अगला वाला समझा. गेट कोड.
now okay. So get code is done, right? Get code you just take
हाँ
like, for
अब वो
example
ऊपर
number
वाला
3.
जो भी है
It gives us C-reg. It does the exact opposite.
ओके
Now
निमोनिक हो जाता है उससे.
on to the main code, pass 1. So what we do is first we initialize linked hash map, which is again it's a dictionary only, which maps string to table row. Now table row is the data structure that we made before, and we make that as a sim tab, which is sim table, symbol table, and then we make an array list of this literature table. Literal table, and then we make pool table. Okay. Literature table. Yes. Okay. Then we make a buffered reader. Okay, that's fine.
वो तो
And this is
पढ़ने
the
के लिए ठीक है.
constructor. So in the constructor, we just initialize the 3 data structures that we need: symbol table, lit table, pool
उसका
table.
कोड था उसमें.
LC is the location counter. It initializes it to 0. Pool table, we actually add the 0 initially because at the starting it contains 0. Like, okay.
हाँ वो स्टार्ट 0 से होता है.
Now we'll go to the main function. All it does is calls this parse file, which is the actual main function. They could have just put it here, but it catches the exception if there's any exception. That's basically it. Now this is the main function, the real main function. Most important. So it's parse file. So what it does is first we read the file, with input.asm. After reading it, we do inst table lookup is equal to new. This basically creates a object of this class so that we can create the mappings easily. We create an object. Okay. And now what we do, we read each line from the this file that we have. We read each line. For that, we take this br.read line. Br is linked with our uh, input.asm.
Okay,
Okay.
okay, आगे बढ़.
Now we have parts. So what are parts? Parts basically we divide this into wherever we see white. This is white spaces, by the way.
अच्छा,
Wherever we
ये.
see white spaces, we consider as one part. So for example, the label is one part, this is one part, this is one part, and this is one part. So there's up to 4 parts. Okay, so now we first check if the first part is empty. So we can have the label is optional. So let's say we have the first part. What it'll do is we'll take the symbol table. Let's say we have a label. It'll take the symbol table. So it'll take the first part, which is our label. So this is our label, and it'll create a new table row object, and we'll create a new table row object, and we'll get the index. So I'll just show you the output. Actually, it'll be easier. See what it takes. Parts of zero. Parts of zero is uh, parts of zero would be the label itself. Then new table row parts of zero location counter. Let's say it's 0. So LC would come as 0 over here, but it's not in this case. And then simtab.get parts of 0.get index. If the label has been defined before, then we get the index of that label. If it hasn't been defined, then we do this code. Okay. If it hasn't been defined, then I think that's why we increment the symbol index over here. Is there any doubts for this part? Like, is there any confusion?
Yeah, can you repeat the else part?
I think, yeah. See, if it contains this part, if our symbol table already has the label, then we do this. Okay, we get the index from the symbol table. But let's say it doesn't contain, let's say there's a new label that we come across, then we simply increment the symbol index. Okay.
Oh yeah. So to go not assign it an address, just go to the next sort of.
Yeah, just go to the next.
Yeah. Got it.
Okay. So check the first part. The first part would usually be our actual operation, like start, move R, add LTRG, etc. So in this case, we do pull tab dot. In this, what we have to do, we have to assign all of the addresses, right? So what we do, one second, which we go from pointer all the way till libtab pointer. Where was libtab pointer defined? Okay, it's initially 0, and then we increment it over here. Over here, it's incremented whenever we have basically DS, IS, in all these cases, we increment the point. In other cases, we keep it the same. So now this should have been written at the bottom actually, but anyways,
Continue.
leave it. Yeah, so it'll take the pointer wherever the current pointer is at the pool table. Let's say it starts at 0, and let's say the LTORG was called at the 5th line, so it'll go from 0 to 5, and we'll keep incrementing the location counter. And what we'll do is literal table. We will just what we'll do is we'll set this the index. So index comma new. We're making an object of the table row where we get the jth index and we get the symbol of that index. Okay.
Basically adding the new literal into the table.
Yeah, we basically add the new literal. You can think of it like when you solve it theoretically, we add the new literal into the table. So that's basically what this does. If you read the code properly, you'll get why we do get and get symbol. Anyways, in this part is basically direct. We do dl comma 01, and then we take the symbol, whatever symbol we have, and we close the brackets. So this is just the intermediate code ka substitution, and we write it onto a file. BW is the writer. Where is it? Yeah, buffered writer. We write it into ic.txt. Okay, then we increment the pool tab pointer and we add that the new lib tab, which means our new pool table will contain a new row basically of this pointer, and we set this to true. I don't know where we use this, but okay.
स्टार्ट का भी ठीक है, बाकी सब भी हो जाएगा मेरे ख्याल से.
Start. You basically you just substitute the location
What
counter.
is expr?
Where?
Expression.
Which line? Oh, the
LC.
expr.
LC is equal to expr वाला.
Oh, I don't know.
Yeah,
Well,
just skip it then.
It'll be something really basic because they use this everywhere. It'll probably be some string cutting thing. I don't know. expr. Okay, I'll have to see this. Yeah, anyways, we write it. Basically, we convert it into intermediate code, and we simply write it to the table. To our file. Every single if you get origin, we change the origin, which means we change the location counter in this case, and then we also write the code onto the file. Okay. Now, if we have EQU, here I sort of did not understand this part. Okay. What is this plus? Does anybody know? Like, why would we use this plus inside of our assembly code? Like,
No idea.
yeah, I have no clue. But something happens here.
Operators
थोड़ा
डाले
स्किप
उसने
करते
हर
रहेंगे
जगह.
हम लोग. सुनना,
हाँ?
मैम को समझाते समय यही करना. मैम को एक दो ऊपर वाले समझा देना, बोलना नीचे के भी सब सेम ही है, वैसे ही होते हैं.
It will just be like, okay, so then after origin, it's EQU. EQU is pretty simple. And then we'll go on to this. Okay.
Nice.
अरे EQ वैसे करता क्या है?
It checks equality, right? But why is there
Sure.
plus? If it
Good
contains
job,
plus,
yeah.
contains minus.
देखते हैं. Contains ये.
It's everything.
ये कब से आने लग गया?
Huh?
प्लस माइनस कब से आने लग गया इसमें?
I don't know. And this is supposed to be a part of the actual assembler code over here. So I have no clue.
कमेंट्स तो लिखने चाहिए थे इसमें. Good.
This is what he wrote. Below if condition are optional. Okay.
There's no
leave it.
IC generated.
Anyways, DC, we declare constant. So it's the same thing. We have a constant and we just simply find the constant with, like, the constant will be, what do you call? What do you call? Colon, what do you call this?
कोलन ही बोल. नहीं.
Colon.
Quote.
Quote, yes, quote. So the quote would be the, what do you call?
The nigga.
Then basically, look at this. 5 comes after this thing. So we replace that 5 with a blank space, and we simply take that as our constant. Okay.
Alright.
So now we write it into the code, and then we write it into the file. Same thing for DS. We replace this part with this, and it becomes the integer. Okay. And we just simply put it as the code, intermediate code, and we write it. And LC plus LC. Oh yeah, the size. Okay, so according to how big it is, we just add it to the location counter. And yeah. Now we have IS. Okay, intermediate. What was this again?
Imperative statement.
Imperative statement. Yes.
Atomic state.
Yeah. Okay. So now what we do is we get the same thing we do. We get the code of whatever parts one has. So if it's parts one. Okay. So if it's like, which one of these are imperative statements again?
I think so. Move R and stuff.
Move R. Let's say move R is a imperative statement. It'll find the code of the move R, and we'll just add it to this part. Okay. So it'll be IS0, and then we'll add our 0. Let's say it's 02. So it'll become IS, 02, and again we have the code. We'll add it to our file later on. And what we do, we see the parts ka length. In this case, like the second part, apparently they only use two parts. They Okay, I see. So they only use two parts. The first part will be the label, and the second part will be this whole thing. Okay. So now we're going to see the rest of the parts length. So it'll keep going until the parts finish. So what we're doing here is replacing all of the commas with what you call the no string. So these commas will be removed basically like that. And then we have if it equals to RG, which means if it's a register, we'll check the part of J if it's a register. So for example, the part this register, we just get we do lookup dot get code. We find which code is the register. Let's say it's if it's a C register, we get 3, and we add the tab space to it. So this is just basically hard coding whatever we get. In what you guys can do is while solving a what you call these types of questions, you can have a paper and pen, and whatever you do on paper, you just convert it into code. So like this part is pretty hard coded.
Yeah.
Yeah. Anyways,
This
if you
part
have
like substitution करके ही समझेगा.
yeah, you have to substitute it, like you have to show it on paper, otherwise it's tough to understand here. So anyways, equals to, you again convert it to blank, like these parts you would just cut out. It'll format itself if you do the math. Like if you take an example and do this code, you'll understand it better. Anyways, like we can copy if they ask us to code it again. That's not a problem. Okay. Okay, so then we have SymTab contains key. If the SymTab contains this key, then we add a symbol. Okay, like if our symbol is already defined in the symbol table, we know the indice of it, and we just add this to the code. If we don't know the indice, we simply increment the symbol index, and then we get the index. I don't know why they didn't just take the symbol index, but yeah, you do that, and then you just add it to this. So it just depends whether our symbol table contains our uh, our label, or what you call, not label, these variables or not. So if the variable is known, then it substitutes. If it's not known, then it doesn't. And we increment location counter. We get the final code and we write it. Okay.
ठीक है, और बस end के लिए भी वैसे ही है. ठीक है.
And end is like L2RG, and then we close this. There are 3 other functions, but all they do is they take the array from 0 to the size of the table,
और
and it
print
simply
करते थे.
prints it out. That's it.
ठीक है.
And oh, EXPR, you guys were asking, right? Oh, this is where the plus and minus comes.
अच्छा.
But expression क्यों use करेंगे?
What's
I
it
don't know.
doing? What's it doing?
It's
It contains the plus. If
देख
it,
रहा है वो, अगर expression अंदर है, if there's an operator,
why will it
उसको
contain?
split कर रहा है वो, white space नहीं, white.
Why will it contain a plus though?
I don't know.
Okay, that's it. And these are the outputs. This and this. And yeah, this is the main output. There are many files. Okay, yeah, fine. I think I'm done.
Yeah, cool.